transition elements and their chemistry. So today at the lab we are going to study ligand exchange reactions. Now I'm sure everyone has carried out salt tests at the lab from time to time, but a lot of us don't understand how these tests work. They work because of these reactions. And today my friends are going to show you the reactions, and then I can explain how the formation of different complexes affect the formation of precipitates and how you can use them to identify salts.
Unrelated copper to sulfate in this beaker. As you can see, it's a very clear blue color. And in these three test tubes, we also take an unrelated copper to sulfate. Now we are going to add aqueous ammonia and sodium hydroxide to two of these test tubes and see how the resulting reaction occurs. First, we'll add some sodium hydroxide. First, drop in a drop by drop basis and then in excess. As you can see, the PPT is a dark blue color. Now what's happening here is the water that was in the copper to sulfate is being replaced by hydroxide ions from the sodium hydroxide. This is a type of ligand exchange that is occurring, and the hydroxide ion is replacing the water, and hydroxide ion is the ligand in this reaction. Now adding some excess to this reaction. Now Tasu will explain what happens when you add aqueous ammonia.
Now again we begin with copper 2 plus surrounded with 6 water molecules, and once we add a few drops of aqueous ammonia, we see the same type of color change. What is happening is 2 hydroxide ligands are replacing 2 of these water molecules, resulting in this complex over here, which we saw with the addition of sodium hydroxide as well. But what happens differently here is that when I add excess of this and I shake it together, the solution becomes a clear dark blue solution. This is occurring because ammonia is a much stronger ligand, and it is able to replace the rest of the water molecules over here and take the place of those water molecules and form this complex over here.
So you've seen the reaction. Why did it happen? This is what's present in aqueous copper to sulfate. This is the hexaqueous copper to iron, where you can see the oxygen from the water molecules forms a dative covalent bond with the copper 2 ion. So they are actually donating their electrons to the copper 2 ion, because the copper 2 ion has empty shells in it. This is why water acts as a negative. So when we and the color of this complex is blue. So when aqueous sodium hydroxide was added in small quantities, some of the hydroxide ions replaced the water ions, forming a dihydroxy tetraaqua copper 2 ion. This was still blue, but it is insoluble, which caused a PPT to form in the test tube. The same thing happens when we add dilute aqueous ammonia. However, the difference was that when we had excess hydroxide, the same complex existed. So there was no change in the state of the precipitate. However, when excess ammonia was added, these amine molecules started to replace the water molecules. And this made a new complex, a tetraamine dihydroxy copper 2 ion. And this one is soluble and is deep blue in color, which is why the solution changed. So this is how ligand exchange allows us to perform salt tests and identify them. Thank you.